The global plastic crisis has reached a critical tipping point. Even with advanced sorting techniques, the scale of the problem is immense.
Innovation begins with a single step, a realization that what was once waste can be transformed into something new.
This is polyethylene terephthalate, or PET, used extensively in containers for liquids. Annually, we produce over
The sorting is complete. Now begins the intense transformation. The industrial shredder reduces the large plastic bundles into reusable fragments.
The clean, shiny plastic flakes tumble rapidly through the hot air drying tunnel. This crisp preparation is essential.
The multi-layered shielding ensures structural integrity even at peak thermal capacity. Observe the precise alignment of the plasma regulators.
Through advanced glycolysis, the long chains are broken down into their base components. A truly circular solution.
Temperature remains stable at 300 Kelvin. Pressure is increasing slightly, but purity levels are holding steady at 99.8%. The liquid precursor oil. A clear, dark, viscous monomer slowly dripping. Raw material refined.
The precursor oil leaves the sterile environment, ready for industrial-scale production. The recycled oil is introduced into the Banbury mixer. Here, it combines with carbon black and rubber under.
Here, the raw rubber is precisely sliced into uniform strips. This measured precision is critical for the final product's integrity. The vulcanization process is complete. The heavy mold opens, releasing the trapped steam and revealing the newly formed tile.
Perfectly molded and deeply treaded. The final product meets our rigorous standards for quality and sustainability. The final inspection confirms the tire's durability. The new compound meets our rigorous quality standards.
Scene 19. The journey to Gaynua begins with the meticulous sorting of high-density polyethylene and polypropylene. Once sorted and cleaned, the HDPE pellets are fed into the hopper, ensuring a consistent flow for manufacturing.
Inside the hot screw barrel, the brightly colored granules begin to melt, transforming into a swirling, thick,
The injection piston drives forward with precision. Molten plastic is forced into the mold cavity, rapidly filling the space under high pressure. As the coolant circulates, thermal energy is slowly released. This precise regulation is essential for the setting process. Scene 25. The injection molding cycle concludes as the robotic arm precisely ejects the newly formed plastic chair, the birth of a product.
Here we see the meticulous final inspection. Dr. Vargas conducts a thorough durability check. Connecting waste and value.
The circular economy begins with waste, which is reprocessed into new products, like tires or chairs.
The process is clear. Now, it is up to us to take the next step. Join us in building a sustainable future.
This mountain of mixed plastic waste represents our next challenge, transforming it into viable construction materials.
Jundels. The process separates flimsy plastic films from rigid containers with unparalleled precision. The plastic flakes and the sand aggregate are fed into a heated, high-shear compounding mixer, where the plastic will bind the filler.
Here we observe the precise moment of transition. The polyethylene reaches its melting point. The The hydraulic piston ensures a measured filling of the composite material, critical for structural integrity. The hydraulic ram descends slowly, compressing the recycled material tightly until maximum density is achieved. Curing time is essential. The bricks must cool evenly on the racks to maximize their durability and strength.
Demolding the perfect brick. Form complete. The initial step in our comparative analysis involves establishing the baseline dry weight of the materials.
The contrast is clear. The recycled plastic brick remains inert, while the traditional clay brick releases a steady stream of trapped air.
The recycled composite brick.
By utilizing recycled plastics, Dr. Vargas and her team are revolutionizing urban development, creating durable infrastructure for tomorrow.
The recycled bricks offer superior durability and a surprisingly smooth finish, proving that sustainable solutions can also be aesthetically pleasing. The integration of the sustainable materials marks a pivotal moment. The process is flawless, a testament.
The microplastic filter utilizes a specialized membrane. As water flows through the treated recycled plastic,
The collected particles, predominantly microplastic fibers and fragments, must be meticulously isolated from the filter.
Here at the primary treatment stage, the new industrial-scale plastic filter units are essential for removing
The
microplastics.
scale of the problem. Microplastic pollution was rising exponentially. Thanks to the new filter, we are seeing a significant decline.
Vargas. Dr. Vargas knew that the work was far from over. But standing here, looking at the restored ecosystem, provided
While the old model is susceptible to weathering and decay, the new composite design provides unparalleled resilience. The linear model is obsolete. Here, the circular economy is realized. Products dissolve and are perpetuated.
We are at the precipice of a new age, a future where human ingenuity and technology converge.
Here in stage 62, the bottles undergo delabeling, a crucial step before the material is granulated into fine flakes. Scene 63. The clean PET flakes. Here, precision is everything.
Ensuring perfect aperture integrity is paramount. Dr. Vargas meticulously examines the spinneret.
Through the spinneret, molten polymer is precisely forced, emerging as ultra-fine continuous filaments, the birth of the fiber. The bundle of fine filaments descends, solidifying rapidly as it meets the cool air, becoming solid
Solid fiber bundle passes over a series of hot and cold rollers, stretching and orienting the polymer chains to increase strength, tenacity building.
The continuous filaments are gathered into a thick, uniform, white rope-like bundle known as tau.
Converting to staple form, the high-speed cutter precisely slices the continuous tau into short, uniform lengths resembling cotton.
The hydraulic press compresses the loose staple fibers into dense, rectangular bales. These are now ready for shipping to textile mills.
Quality assessment requires precise tactile verification. The crimped staple fiber must meet stringent standards for both softness and tensile strength. The short staple fibers are fed into a ring spinning machine, twisting them into long, continuous, fine yarn.
Once wound, the cones are inspected for uniformity. This ensures a flawless transition to the weaving stage. Here, the warp and weft converge, creating the very fabric of our future. Dr. Vargas ensures the precision is absolute. Here we see the initial assessment of the gray fabric. Evaluating the weave tension ensures optimal consistency for the subsequent dyeing process.
The recycled fibers immediately absorb the reactive dye. This precise immersion process ensures vibrant,
This is the ultimate product. Activewear designed not just for performance, but for the planet.
As the regulated air flows through the recycled fibers, the moisture vapor transmission rate is precisely measured, validating the fabric's performance. The recycled fabric is stretched to its limit by the machine. The tension graph shows extreme durability before breaking. Durability confirmed. Here at Scene 83, Dr. Vargas oversees the intricate process of transforming recycled fibers into durable, wearable garments. This collection represents a monumental step forward, proving that recycled materials can meet the highest standards of modern design.
As the label clearly states, this garment is made from 100% recycled plastic bottles. The microscopic view reveals the structural integrity of both fibers. Virgin polyester on the left, and our
The green advantage is clear. We've achieved significant reductions in energy use, water consumption, and CO2 emissions.
From the laboratory, the transformation begins. Waste becomes opportunity. Tires grip.
Scene 91, targeting mixed rigid plastics. These industrial bins are filled with materials previously entrances. The robust industrial shredder blades violently grind the thick, rigid plastic pieces.
The melt-blown process begins when molten polymer is extruded through fine nozzles, then stretched by high-velocity air.
As the fibers accumulate on the conveyor, they form the thick, uniform layer known as the insulation bat. The automated system first compresses the bat with a soft hydraulic press. Then the high-speed blade precisely slices.
The thermal testing device provides a precise R-value measurement. This data is crucial for assessing the recycled insulation's efficiency.
The recycled polymer fibers are easily handled, providing a snug fit within the standard wall cavity. Here we see the extrusion head for pipes. Thick, molten black HDPE is forced through the die, shaping the flow into a continuous tube.
The continuous pipeline represents a leap forward in sustainable infrastructure. Dr. Vargas ensures Here we see the automated system cutting the pipe into specified lengths, ensuring smooth and consistent edges every time.
The fusion process begins as the recycled pipes meet the heated plate. Precise pressure ensures a seamless.
The installation of the high-density polyethylene pipes is a critical phase in modern infrastructure development.
Dr. Vargas evaluates the structural integrity of the high-density polyethylene, ensuring it meets the stringent flexibility requirements for subsurface deployment. As you can see, the finished recycled HDPE pipe exhibits perfectly uniform, non-porous wall thickness.
As you can see, the metal pipe corrodes rapidly. Our recycled high-density polyethylene, however, as Dr. Vargas demonstrates, these recycled solutions offer both structural integrity and superior thermal insulation for modern building challenges.
As heat scales an uninsulated home, energy is wasted. Our recycled insulation stops the loss.
The recycled insulation fills the walls completely, working in tandem with the recycled pipes that deliver clean, secure water throughout the home.
Precision is paramount. The extrusion process requires constant supervision to maintain the structural integrity of the materials.
This shredded material represents the first step in transforming complex plastic waste into reusable feedstock.
The machine injects the recycled material under high pressure, forming a precise, complex component. Here in the main distribution hub, Dr. Vargas ensures every coil of pipe and every bat of insulation.
Measurable success is evident. The volume of plastic diverted from landfill continues to accelerate rapidly.
The tactile quality of the recycled fibers provides clear haptic proof of its soft, yet resilient structure.
From the structural piping to the advanced insulation, every element is designed for maximum efficiency. The result The key to high-purity recycling begins with meticulous sorting and cleaning. Only flawless input, like the
Stage 1, 2, 3 complete. The purification process has successfully eliminated all residual contaminants, ensuring the integrity of the recycled polymer.
The process begins with the rapid heating of the rPET sheet, followed by a vacuum draw into the mold.
The specialist material stream begins as the recycled chips are precisely poured into the extruder hopper. This is the first step in creating high-quality filament. The micro-extrusion process demands absolute precision. Here, the polymer is heated and forced through a 1.75 millimeter die. The finished filament is wound neatly and tightly onto the spool, ready for immediate desktop use. The process ensures perfect consistency.
Utilizing recycled filament, Dr. Vargas initiates the printing sequence. The future of sustainable manufacturing begins now.
Seamlessly integrating design and production, the process yields a flawless component with zero material waste.
The key objective was performance parity. As you can see, the recycled material shows no degradation in quality compared to the virgin filament.
In this supermarket application, the rPET packaging protects the produce effectively. Dr. Vargas confirms the integrity of the design.
Every detail matters. This marker confirms the ethical choice: 100% recycled content, diverting waste from landfills and into new products.
Here in the printing lab, Dr. Vargas oversees the future of manufacturing. Through innovative processing, we can achieve complete landfill avoidance.
We are effectively closing the loop, turning waste into new products.
Assembling the final product requires precision. The recycled plastic is rapidly formed and sealed, overseen by the team, ensuring peak efficiency. This intricate piece demonstrates the potential of our recycled filament, combining artistic freedom with precise, sustainable manufacturing. As the layers build, the structural integrity of the component is maintained. This level of precision is exactly what we need for the upcoming trials. Observe the transformation. The raw material is purified into flawless rPET pellets, which are then extruded into perfect packaging and filament.
From tires to textiles, bricks to advanced packaging, Dr. Vargas has successfully synthesized our comprehensive closed-loop solution.
The data confirms a sharp acceleration in processing capacity. We are now handling tons of plastic.
The process begins by transforming waste into a reliable, sustainable resource. From pellets to plate.
This is the result of meticulous science. Water, once thought lost, now flows cleanly through our essential infrastructure.
Recycled plastics provide a sterile, yet supportive environment for accelerated growth.
Addressed. By increasing the global recycling rate, the swirling plastic vortexes polluting our oceans are rapidly shrinking.
Behind every recycled product are the dedicated efforts of a focused workforce, ensuring precision at every step. In a system defined by precision, the human element remains paramount. Acknowledgement ensures the continued success of the operation. Here at the next frontier, advanced chemical recycling allows us to break down even the hardest to sort polymers into reusable hydrocarbons.
As this comparison shows, advanced plastic recycling offers a significant efficiency gain over traditional virgin oil.
Dr. Vargas carefully loads the unlabeled batch of plastic into the pre-treatment chamber, isolating the contamination before the next phase.
The global reach of this technology is expanding rapidly, with new recycling facilities coming online across 5 continents.
The successful reclamation of this site proves that the age of the landfill is finally over.
From waste to resource, this high-grade plastic demonstrates a perfect molecular structure, ready for its next life.
Utilizing high-grade recycled materials, the new prototype demonstrates the expanding applications of sustainable aerospace technology.
Foundations. From our infrastructure to the clothes we wear, recycled materials are integrating seamlessly into our daily lives.
The future of clean waterways is here. Through dedicated research, we have restored this vital resource.
The innovation continues. With the new catalyst, the breakdown is faster than ever. This is the future of sustainable engineering.
The recycled composite bricks developed by Dr. Vargas provide a durable and safe pathway, showcasing the lasting impact.
The successful integration of our scientific endeavors into the natural environment represents the culmination of years of dedicated work. The global recycling movement is a unified effort, transforming countless particles of plastic waste into
recycled rubber presents unique challenges, yet our process ensures flawless durability and superior wet grip, even under pressure.
The process begins by breaking down existing materials, transforming them into a fiber that is both soft to the touch and incredibly resilient.
The smooth, flawless interior of the recycled pipe is critical. This non-corroding surface ensures both health and longevity for the system.
Under the precise guidance of Dr. Vargas, we have transformed waste into the building blocks of tomorrow. This is the full solution.
Invest in the circular future. Educate the next generation of recyclers. We invite you to participate. By choosing recycled products, you wield significant consumer power. Patience. Global unity is the cornerstone of true sustainability. By working together, we can achieve our...
This is the moment where theory becomes reality. A moment of profound achievement for Dr. Elena Vargas and for us all.
The recycled materials undergo rigorous testing to ensure unparalleled quality and lasting durability.
The earth, clean and green. This is the ultimate vision realized, a testament to what it
Innovating for a sustainable tomorrow.